we are from group 13. We will explain to you about our paper. The title of our paper is The First Approach in Planning Renewable Energy Source System using Photovoltaic System. Now, let me introduce our member. My name is Ilham Rafi.
My name is Dr. Samutra.
My name is Adi Rianto.
My name is Nandifa Dalila.
And that is our member. Now I will explain to you why the introduction of this paper, why this paper is important. As we know that electricity is one of the biggest problems around the world because the demand of electricity keep increasing while the supply of electricity is decreasing. One of the best methods to solve this problem is by using renewable energy. Because renewable energy, the amount of electricity in renewable energy resources will not decrease. One of the best option in renewable energy is photovoltaic. Photovoltaic system is renewable energy system where we convert sun energy from the sun to electricity. The most biggest problem in Indonesia especially is a lot of people, especially engineering and students, don't know how to apply photovoltaic system in real world. So in this paper, we will explain to you briefly about how to plan this photovoltaic system in a certain specific area. It is important to know that in our paper we will only talk briefly. It's only a simple method in planning the photovoltaic system. The full method, the complex method that will be used in real plan will not be explained here because it takes a lot of time to explain it. Now I will explain to you what is inside our paper. The first chapter we will talk about the important component in planning the photovoltaic system. The second chapter we will talk about the 6 easy steps to calculate the possibility in planning the photovoltaic system in a certain specific area. And in the last chapter we will give you a conclusion of this paper.
Second chapter, we will discuss about the basic element of PV modules. But first, I'm gonna tell you what is PV module is. PV module is an energy converter that convert solar energy into electricity. If you want to arrange PV module, there are two types of arrangement that you can make. The first one is series. Series arrangement, it can add up the voltage, but the current remain the same. And the second one is the parallel one. If you arrange it parallel, you can add up the current, but the voltage remain the same. And before we discuss deeper about PV module in this chapter, we have to know the term that we are going to use in the chapter. The first one is VOC. VOC means the voltage open circuit. VOC is the most optimum voltage that can produce the highest power. Not the highest voltage, but the most optimum. And the second one is ISC. ISC is current short circuit. It means the most optimum current that can produce the highest power. And we will discuss about special type of PV module. It's called thin film modules. Thin film modules have much more advantage than the normal PV modules. The first one, it's much more flexible. Because it's flexible, so you can plan it much more easier than the normal PV module. But it have also disadvantage. Of course, because the special one, it's very expensive. So the thin film modules have its own advantage and disadvantage. And After this, my friend will talk the next basic element of PV modules, MPPT.
Now, the next part, the next main component is MPPT. MPPT itself is not a component in a hard component, but it is an algorithm that will be used to make the control system. What is MPPT? MPPT is maximum power point tracking. It is an algorithm to find the most optimum power point that will be delivered from the photovoltaic system. What is the optimum power point? Optimum power point is the point where voltage and current will give the most optimum power, where the connection of voltage and current will give the most optimum power. There are two types of MPPT. The first is the direct method MPPT algorithm, and the second is indirect method MPPT algorithm. The example of indirect method MPPT algorithm is fixed voltage method. Fixed voltage method is a method where you use a fixed number, a fixed constant, and you calculate using the fixed constant to find the maximum power point. As we know that from the title, indirect method didn't use any sensor. The second example of indirect method is fractional open circuit voltage. This is one of the most accurate method to find the most power point to use in MPPT. But the problem is, if we use the fractional open circuit voltage method, we should stop the operation of power plant and we should measure the open circuit voltage manually. So we should stop the operation. Now we go to the second MPPT method. The second is direct method. This method, we will use sensor in this method. The first example of this method is perturb and observe algorithm. This algorithm, we use perturbation in the system, then we will see whether the power point itself is the optimum one or not. If it was not the optimum one, the system will change the point and the system will give the perturbation again. So the cycle continue and we will see whether the power point is optimum or not. The second direct method is incremental conductance method. This method we will use what we call conductance variable. But because of this method is really complex, we don't discuss this method here.
Now I will explain to you about the photovoltaic converter or inverter. The photovoltaic converter is a tool that we use to convert DC current to AC current or from AC current to DC current. An ideal PV converter can draw the maximum power from the PV panel and supply it to the load side. In general, PV converters should have the following characteristic. The first is the inverters should be highly efficient because the owner of the solar system need a maximum power to be delivered to the grid. The second, PV converters can face the temperature and humidity. The PV converters can operate in many or various temperature and humidity. The third is PV converters have a safety feature and in silent operation. The next is the type of the photovoltaic converters. The first is central inverters. Central inverters is the simplest photovoltaic converters. This type is produce high of the power. And the second is module integrated inverter. These inverters operate at one or several PV module and produce power lower than central inverter. The third is string inverter. This type is the photovoltaic converters that combination of the type of central inverters and module integrated inverters. And the last is multi-string converters. This type consists many type of the string inverters.
Okay, now I will tell about the fourth main. The fourth main component, there's battery. Battery is electric-chemical devices that convert chemical energy to electrical energy. There's two types of battery. The first is primary battery that convert chemical energy to electrical energy irreversibly, and the second is secondary battery that convert chemical energy to the electrical energy reversibly, and it used usually for PV system. And I will tell about battery's parameter. There's three parameter of battery. The first is voltage. Voltage for solar batteries or lead acid and lead batteries that are usually rated at 12 volt, 24 volt, and 48 volt. The second is capacity. This refers to the amount of charge that the battery can deliver at the raw voltage. The third is battery efficiency. For this system, usually the amount of efficiency is used. Which is given as the ratio of total storage output and total storage input.
In the third chapter, we will discuss how to design PV system. There are 6 simple steps how to design PV system. The first one is determine the total current and operational time. We have to calculate how many items we want to connect to the PV modules. For example, if you want to connect the television, computer, refrigerator, and etc. We have to calculate how much power this item going to use from the PV modules. The second steps, we have to add system losses. In PV modules, there are some components that need energy to be activated. For example, batteries. So we have to add 20 to 30% energy more power from the first step that we have calculated. The third step is determine the solar irradiation in daily equivalent sun hours. We have to calculate whether we want to use the PV modules full 1 year or only in several seasons. For like example, the PV module efficiency is much higher in summer than the winter. So we have to calculate it. And to get the most optimum power, we have to configure the tilt angle of the PV module so it can absorb as many solar cell as it can.
The fourth step is determine the total solar array requirement. In this step, we must calculate the total current needed before we build the PV system. And the fifth step is determine optimum module arrangement for solar array. In this step, we must choose the best arrangement for solar array. And the last step is determine battery capacity.
Okay, finally we come to the conclusion. As you can see, we already give you the main component that you need in planning the PV system in the second chapter. And in the third chapter, we have already told you about 6 easy steps that you could follow if you want to plan a simple PV system by your own. Now, we really hope that this paper could give you a lot of help in planning your own simple PV system, and even for non-engineer.